Thank you, Matt, and thanks Heavybit again for hosting, and Sodexis for the beer and pizza. So tonight I'm going to talk about debugging video and how to make it better. So we're going to talk a bit about understanding what your video is doing, some tools and ways that you can inspect and measure what's happening, and then look at a few approaches for improving and fixing things. So there's a few areas we're going to explore tonight. First is looking at metadata, so some tools that you can use to look at containers, at adaptive manifests, and codec and media information. Then we'll talk a bit about encoding quality and various approaches and tools that you can use to understand the visual quality of your encodings. Then we'll look at player errors and quality of service and how to ensure the best experience for your users. And finally, we'll talk a bit about delivery, CDNs, and how multi-CDN switching can help to improve the delivery experience to your customers. So first, talking a bit about metadata, there's a number of tools as a video engineer on a day-to-day basis that I like to use. One of the first ones is ffprobe. I'm sure a lot of you have used it. It comes with ffmpeg. It's great for, hey, I've got a file, I want to figure out, what's the resolution, what's the bit rate, or any other metadata about that file. It can be useful as well when I'm modifying encoding settings and I want to figure out, hey, where are the keyframes in that file? Media info is also a great tool for exploring file metadata. More recently, I've started using it a lot more with adaptive manifests as well. You can give it a URL to an HLS or a dash manifest, and it'll parse that manifest and give you out metadata and information about that manifest in a really easy to read and consume fashion. When working with MP4s, and particularly fragmented MP4s, the Bento 4 toolkit is great. There's tools for converting progressive to fragmented MP4s, for dumping the MP4s and looking at the atom map and structure of the MP4s, and lots of other useful tools in there. Then looking at more on the adaptive sort of tool side, Apple has the Media Stream Validator tool, which is great for validating your HLS manifests and your media segments, looking at the bitrate and various other settings that that tool will validate. And from -if, there's a similar sort of tool for conformance and validation there. So next section, we'll get on to talking a bit about encoding quality. So primarily in this area, in what I've been looking at, it's been looking at quality differences between different encoding settings. So as I've been modifying encoding settings, trying to optimize and trying to change things, trying to figure out sort of how that's having an impact on the quality, and also having a look at the quality differences between the different renditions in an adaptive bitrate ladder. So with all of these tools, you're looking at comparing a source file to a distorted or modified encode of that media. Generally, with most of these tools, they're going to expect and work with the YUV color space and raw video frames. And when you want to compare different resolutions of files, you need to start looking at how you scale the smaller version back up to the same resolution as the source before you pass it into most of the comparison tools. So with ffmpeg, you can do a few of these things. So with ffmpeg, you can use the raw video format to get out frames in a raw format in the YUV color space or whatever else you require for your tools. And with ffmpeg, you can also use the PSNR and SSIM filters directly built into ffmpeg to run those quality measures. So out of that tool, you'll get a summary at the end, which is what some of that text there is showing. And then you can also get a log file out that shows quality for every frame in the file. So over here, there's a few examples comparing two different encoding settings. So at the very top, that was the original encode. The one just underneath is showing another encode that we did, where you'll see that the quality is slightly dropped, but in achieving that, we've dropped the file size about 30%. So that has a massive impact on bandwidth. And then at the bottom here, this is showing the PSNR values over all of the frames in the file. So one of the interesting areas, you can see sort of where the video is less complex, where it's easier to encode, where all of the renditions are sort of coming together. One of the other interesting tools in the quality comparison space is something that Netflix have open sourced more recently, the VMAF tools, and I believe there's a talk on this at DMUX next month, so not going to go too much in detail about it, but it's sort of more focused on trying to come up with a perceptual video quality assessment. So that's trying to be more tuned to how the eye perceives video and optimizing encodings and quality for things that humans will perceive as higher quality. So then the next area I want to have a bit of a look at is looking at player errors, QoS, and video experience. So in this side, I'm looking at integrations into your video players, which could be on web or any of your other platforms, and starting to send data back from your clients so that you get a deeper understanding of what's actually happening in your video player, what experience your users are having, and then collecting data that you can use to improve that experience. In this space, there's a number of vendors. So then the first area here is talking about fatal errors. So errors that stop playback immediately. So these are ones that you generally want to pay a lot of attention to, because this is when a user is having a pause or a permanent stop in their playback experience, and generally having a bad time. So in general with these, the HTML5 MSE errors aren't necessarily always that descriptive. There can be lots of different causes of this. It could be you're passing file formats that aren't supported by certain devices. You can have all sorts of different compatibility issues between browsers and OSs, and then CDNs can also play an impact on this. You may just be having a period where you've got a CDN availability outage and you're not getting all of the data to your customers reliably. So in this slide here, this is showing for IGN our error rate over the last 30 days. So you can see we're now at a relatively low error rate at sort of just under 4%. But what I wanted to highlight on this is it's showing a breakdown by browser version. So we can see that there's sort of three browsers at the top there, Chrome Mobile 38, Chrome 41, and Chrome 42, that are having a much higher rate of playback failure, and in the case of one of them, a 100% error rate. So in that case, that's fairly low-hanging fruit. It's something that we can go in and reproduce and start to explore, why these users are having errors and try and resolve that so that we deliver a better experience. So once we sort of have at a high level, I'd sort of go in and start to look a bit deeper, look at, okay, what is the error that this user is having? So in this case, this is an example of where it's a sort of standard HTML5 media error. This, I believe, was a code 4 error. So we get an error message that in itself doesn't necessarily give us too much more information, but it's another starting point and another piece of information to dig deeper as we're debugging this issue. And then the next thing I do is go and dig a level deeper. So this is looking at an individual view. So this is a single user, a single view. And in this case, we're seeing that the error happened right at the start of playback, and that it was an error with no compatible source found for this video. So at that point, I'd start to look at what format media are we providing, what does the device that user's on support, and have a reasonable amount of information to start sort of further exploring and solving these problems for our users. So the next area on this I want to dig into is talking about user experience. So fatal errors are bad, users will have those and maybe not come back, but the issue for most of your users once you have a lower error rate is improving the experience, is delivering video to them with the minimum amount of startup time. So if your page and your players take too long to load, users will start leaving before they even watch a video. So we can see here there's just under 8% of exits before video start. So if we could improve the startup time, there's potential that those numbers could decrease and we could increase engagement in our videos. The next area that can have a significant impact here is rebuffering. In this day and age with Netflix, YouTube, all the big video platforms, rebuffering is becoming not as often an occurrence as maybe it once was with adaptive streaming. It's something that we now can improve a lot more with a lot of these metrics that I'm showing up here. So currently we have a rebuffering percentage of about 15%. So about 15% of the time that people are viewing our videos, they're experiencing a rebuffering event. A lot of this is progressive today, so potentially that could be improved in the future with adaptive. And then the other metric I'm displaying at the bottom there is the rebuffering frequency, so the number of rebuffering events that our users are having on average during playback. And then the final experience area that I wanted to talk about was around upscaling and downscaling. So when you have upscaling, we're delivering a video that's a lower resolution than the window that the user is viewing it in. So it's going to be upscaled, they're going to see artifacts, they're going to be seeing video at a lower quality than they could or than they should be. So again, with progressive, a lot of these are fixed rendition resolution, so adaptive could also help to improve this. And on the other side, the downscaling percentage represents when we're serving a larger video than the size of the window. So in this case, we're just wasting bandwidth. It's something that we could reduce our costs if we're able to deliver a size of video that fits closer to the player size of the user. And then the final area I want to talk about tonight is CDN delivery and performance. So getting the bytes from some network through to your end users. So for IGN today, we're delivering to a global audience in many countries. The internet is not necessarily always a friendly place. There's CDN issues with capacity and throughput, with network links that the CDN providers sometimes getting saturated, with outages in various points of presence in a CDN operator's network. Then there can also be issues in other points in getting to your user. So it could be in ISPs and in routing around the internet that's slowing down traffic between your CDNs and the ISPs that your customers are on, or even within ISPs, or even at the end user with problems with their device, with slow Wi-Fi, with slow 3G. So overall, no one CDN is necessarily always going to be best at serving every customer. One tool that gives a great insight into this is from Sidexis. They're at live.sidexis.com, they're Radar Live, which is showing some of the billions of metrics that they're collecting on different ISPs, on different CDNs, and it's showing where they're, with their real user measurements, they're collecting data on where these problems are in the internet and in different CDN providers. So in this graph here, it's comparing two CDNs. We can see that clearly one CDN up here, Fastly, in this case, this is showing throughput over the last 30 days, is performing a lot better than the other CDN here down the bottom. It's an anonymous CDN that may or may not start with an A. So then, so for the US, you'd look at that data and go, okay, great, I should always use Fastly. But we're delivering to a global audience, and CDNs aren't unfortunately, always great everywhere. So this really sort of shows you how, when you then look at Australia, at the start of the month, Fastly was doing great. Then later into the month, there was a bit of a rocky period there, and then it recovered again at the end. So what this is sort of showing is a lot of the variance and fluctuation in throughput across a month for two CDNs. So this is where multi-CDN switching can be really valuable, is at every view, or potentially if you have longer streams, even midstream switching could be valuable, where you can always be picking the right CDN for your user. And then real user measurements and various other sort of techniques of collecting data so that you can make, or you buy tools or use tools to make the right decision, can be really valuable in achieving that correct decision for all of your users. Routing on the right areas and priorities that are important to you is also really important. Looking at things like availability, so when you have an outage on a particular CDN in a particular region, that's often one of the first things you'd want to route around. With adaptive streaming, throughput is probably then one of the next most important criteria, making sure that you're getting data to your users at the highest bandwidth and highest bitrate possible. But then other factors for live latency could potentially be a concern. And then also looking at your CDN contracts and balancing how much data you're sending between different CDN providers. Which also leads into the next point here, which is by switching to multi-CDNs, you start to gain a bit more leverage in your CDN negotiations and contracts, and have more flexibility in being able to work with multiple vendors that are delivering the best service to you. One of the things to watch out for as you start to move into this is cache hit ratios can certainly be decreased by moving into a multi-CDN world. As you switch to 2 or 3 or more CDNs, your cache hit ratios in each CDN are likely to be lower, so it's just important to keep an eye on that, as initial hits when content is cold can deliver a worse user experience for those users, and can also end up costing you more bandwidth and requiring that you use more servers at your origin and have greater throughput at your origin. Yeah, well, that's actually pretty much it. So there. Yeah, nothing is convenient when you're working with with big CDN providers. Support is always going to be challenging. Managing relationships, getting what you want, and necessarily having enough insight into the systems is really difficult. When you build out your own private CDN and run your own CDN, there's a lot of initial complexity in setting up and maintaining all of that infrastructure and architecture, but once it was going, where I was last at Mubi with the private CDN we built, it got to a point where operationally it was less work, and we were lowering costs, but once you get to much higher scales, it's a much bigger sort of piece of work to achieve. I would say not quite yet. I think that's something that, for us, there's a lot of areas there that we, want to be collecting more data about and understanding, if a user is leaving, sort of why is it that they're leaving. There's a lot of impacts that I didn't show tonight around like page load time and ad times and various other factors that we're also trying to quantify but don't really have a solid number for and reasoning for just yet. Yeah, that's not really something I've explored too much. Most of the, you can sort of try and compare some of the quality values that you have, and I know there's various work that people are doing around trying to sort of build larger data sets and use machine learning to sort of gain more understanding over a sort of larger comparative data set, but most of what we've been doing so far has been sort of reference versus distorted sort of comparisons. Yeah, that is a challenge at this point, because getting access to that data is fairly difficult at this point. We don't really have sort of any direct ways to sort of collect that. We are starting to look a bit more at collecting logs from a CDN, so from this sort of CDN backend, and doing sort of more aggregate processing for various purposes. So potentially that could be one avenue that we could start to look at it. But because a lot of those logs are delayed, often by hours on certain providers, it's not necessarily going to be enough to do any real-time sort of decision making and routing based on that. Cool. Thanks. Thank you.